All right, so today we're going to be looking at problems that require us to solve that have variables on both sides. So this is my equal sign here. I'm going to draw my line just to separate my equal sign and my sides, right? So the first thing you have to do is combine like terms. So I'm going to look for any terms that I can combine, and I'm going to circle or box, put a box around them, or a fish or a heart, whatever, just so that I know that they're similar. So I have a negative 12 that I'm going to circle. My negative 7x has an x attached, so it's not like my 12. I'm not going to circle it. My plus 1 is just a number, an integer. I'm going to circle it, and then I'm going to put a circle around my plus 4. I kind of covered these up, so this is 5, right? 4 plus 1 is 5, and this is a negative 12. So if I'm not sure about whether it's going to be a positive or minus, I could always use my column method. This 12 is going to be negative. 4 plus 1 is 5. That's positive on this side. I'm going to subtract 5 from 12, and that is going to give me a negative 7. So I end up with a negative 7, and whatever I have left up here is my negative 7x. My equal sign on the line, remember that line represents my equals, and it separates both sides. And here I have negative 7 and minus 7x. And if you look, these guys are identical, right? So this is what we call identity property. So if I added 7 here and added 7 here, I would get 0. So let's just go ahead and do that. Plus 7, plus 7. This is going to be 0, and this is going to be 0. And if I added 7x here, and I added 7x here, right, I would get 0 and 0, which I end up with 0 equals 0. So when I have a problem that gives me 0 equals 0, my answer is going to be a little bit different, a little special. It's going to be all real numbers, or it can also be stated as infinitely many, because the number of solutions to this problem, x, can be actually any real number. So you want to look for either one of these possible answers when you have a problem that ends up as 0 equals 0. Go ahead and push pause and make sure you get this copied down, and then we're going to move on to our next problem. What my most important point for this side here is that I want you to remember to combine your like terms before you try to solve anything. All right, so let's move on to the next one. Here we have a variable on this side and a variable on this side. So I'm going to go ahead and I'm going to draw my line down here. And this would be a good time to use that reveal, because I want to look at just one side at a time. Did it work? It's not working. There we go. Oh, it worked and then I didn't. So let's look at one side at a time. So we're going to look at this side of the equal sign first. I have negative 17 plus 2a. I can't combine any like terms. There's nothing else that I need to do on that side. So I'm going to go ahead and swap over to the other side of the problem. Here I have some parentheses, right? So I need to use my distributive property to remove my parentheses. I have 3 times a 6a. 3 times 6 is 18, and my a tags along. Then I have a 3 times a positive 5. 3 times 5 is 15. It's positive. And there I go. So now I have this side that I can just bring down. I'm not doing any changes to it. And I have my side on the right. So the goal is to have the variable on one side or the other. I don't care what side it is until the end. So for now, I'm going to look at that and see that 2a is smaller than 18a. So I'm going to move that over first. And I could do my number or my variable first, but I prefer, it doesn't matter which way you do it, I prefer to move my variable over so I know where I'm moving my number to. So subtracting 2a from 2a, because I'm adding the opposite, that's my inverse operation, right? And then I'm going to subtract 2a from 18a, which is going to give me positive 16a. And then I can bring down what's left on either side. This is a negative 17 is equal to 16a plus 15. So my first step on this problem was to use distributive property. My second step was to use the inverse, right? So I'm going to say I move smaller variable using inverse. Operation. And now my third step is going to be to move my whole number using inverse operation. So inverse again. So I'm going to subtract 15 and subtract 15. And the reason I subtracted the 15 and not the negative 17 was because, remember, I want my variable alone on one side. I've already moved it over this way, and it's positive, so it's just easier to do that. When I subtract two negatives, it gives me a bigger negative, so I'm actually adding them. This gives me 12 plus 1, 32 is equal to 16a. And then this time, it's the multiplicative inverse. Which is actually division. So the inverse operation of division multiplication is division. I'm going to divide both sides by 16. This becomes Juan. I'm going to write my a on this side, and I'm going to use my commutative property and swap it over to this side. So a negative divided by a positive is going to give me a negative answer. 32 divided by 16 gives me 2. So a is equal to negative 2. Push pause right now and make sure that you are copying all this down in your notes. This is going to be very handy when you actually do the work that I have for you today. All right, moving on. We're going to do a little bit more. 4b minus 4 equals 6b minus 2b. So let's go ahead and draw that line down there. And this is actually very similar to what you had to do in class yesterday. So I'm going to start by looking at this problem on this side. Because I notice that I have like terms. I have a positive 60b and a negative 2b. So I'm going to go ahead and subtract 2 from 6, which gives me 4, and my b tags along. And then I'm going to bring the rest of this down here. So if you notice, both of these are the same. So if I subtract 4b here and 4b here, this becomes 0, and this also becomes 0, which gives me an answer of 4 is equal to 0, which is not true. So when they don't equal, and you get an answer that looks like this, your answer is no solution. That's your answer. So one possible answer would be all real numbers are infinitely many. Another possible answer would be where you get your variables equal to a number, positive or negative, maybe even a fraction. And the third possible solution would be when they don't equal and your answer is no solution. All right. These are some really good notes, 3 examples of some problems that you'll have in class today. and let's get to work.